What's up guys, happy Sunday. Thanks for tuning in to the latest Life of a Jobbing Plumber video. Slightly different format this week in that it's one job start to finish. Normally I like to throw a few jobs in, mix it up a bit, but this week, Monday, Tuesday, I was with Marcus. We did a Vaillant system boiler install, flush, controls. So it's that job basically. There was also a pipe bending tutorial, but that was 15 minutes long on its own. So I've put that as a separate video that I released yesterday. If you've not seen that, I'll link that at the end of this video. So how's your week been? I had one of those jobs on Wednesday that I've not had one for a long time, but when you get into a boiler fault finding thing and you're just there for hours and you just want to give up and come back another day and just reevaluate your career choices. I had one of those. I flooded a backseat, literally soaked the PCB. Yeah, it was a nightmare. Luckily for you, I was filming it for YouTube, so I've got the footage of the moment where I pulled a live pipe off and just flooded the place. Yeah, I'm going to put that out Wednesday or Thursday this week, so look forward to that. So yeah, that happened on Wednesday. It's Sunday now, so I've just about forgot about it. If you while you're here, if you can like the video, if you don't subscribe, if you could click the subscribe button, because that will really help me out, encourage me to make more videos. And I hope you enjoy this week's video. On a job with Marcus today. Tell us what we're doing.
So we're basically taking out this old house-led system boiler.
Yep.
We're going to replace it with a Vaillant boiler, and we're going to try and alter the pipework so it all works properly. So it's had issues since it's been in.
This pipework, this is weird. If you have a look under here, well, it's weird to me because I haven't. Have you ever seen it before?
Nothing like this.
So this middle one, ignore that. That's the gas. But we've got. I've looked at the instruction manual. This is the central heating flow, and this is the central heating return. Obviously, we can also put, as a system boiler, hot water cylinder on that. But this pipe here, which they've teed in with the return, is meant to be for a secondary return hot water return. So no, was it flow? Anyway, we'll look at the instructions and try and work it out, but apparently it's never really worked properly, so we've got a bit of sorting out to do. We're just putting a standard system boiler in, aren't we?
Yeah.
So I found the instruction manual for this boiler online, CBX and SBX. It's either a combi boiler or a system boiler, and it gives you various diagrams. So here's the central heating SBX system boiler pipework diagram. Primary flow, central heating return, and secondary return from the hot water. And then there's a system diagram which shows on the boiler there, the return from the radiators being on the right, the flow to the 3-port being in the middle, and the return from the hot water being on the left. And then we've got another diagram in the same booklet which shows on the bottom right there, heat and return on the left, return from the water in the middle, and the heat and flow on the right. So you heard at the start of the video, Marcus said that the customer had said that this system has never really worked properly, and I don't really blame the installer because it's not even clear in the book. And you can see here on the wall jig when we've took the boiler off that the flow is on the right, secondary turn is in the middle, and the return from the hot water should be on the left. So I've drawn this diagram. So in the boiler manual, this is one of the diagrams they give you. So flow in the middle goes to the 3-port, flow into the cylinder, flow to the radiators, and then return from the radiators on the right, return from the cylinder on the left. But the job we've got is piped up like this. So they've taken the flow into the 3-port, to the radiators and to the hot water cylinder, and then the return coming back from the cylinder, the return coming back from the radiators, they've took together into that left-hand connection. And then they've just joined in and gone into that secondary return connection on the boiler like that. So if it is according to the diagram in the manual that the return is on the right and the flow is in the middle, then it never was going to have worked properly. But having said that, we've also got the diagram in the manual where the flow is on the right, which is what they've done, and then the return from the central heating is on the left, which is kind of what they've done. but the optional secondary return, why they've done that, I don't know. If you're watching this and that makes sense to you, this diagram, and what it is actually like, then let us know in the comments.
Right, so because this is on an unvented hot water cylinder, we've got a 3-port and a 2-port. But all the 2-port actually does is it cuts off the hot water supply if anything goes wrong. So it's basically just a thermal cutout. So let's say thermostat packs up on the cylinder, gets up to 90 degrees, it'll shut off and stop it. Or if the 3-port wedge is open and it's just constantly cycling.
So it's like a backup to the 3-port.
Yeah. Obviously this is mid position, so it's not always guaranteed to shut off.
So you can see we've got a bronze pump in there. That's our secondary return for the hot water. I'll probably do a little diagram on how that works now. We'll look at it, but basically it pumps a circuit of hot water around the house because it's a big house, so you've always got some hot water roughly available near where your outlets are, but we'll do a little diagram on that. So we're going to leave that in. We've got to try and wire that in. So we've got a bit of messing about to do, really, haven't we?
Yeah, just about and tidying up.
Right guys, so I've got my plumbing book, my pen and paper, and we're going to try and explain to you secondary circulation or a secondary return and keep it as simple as possible. So we've got our stored hot water cylinder here. Obviously cold comes in at the bottom, it gets heated directly or indirectly, and then you've got hot water outlet at the top that goes to your taps. Now I've only drawn one tap on for now, but this is our tap that's furthest away from where the hot water is stored. So imagine in a normal house, let's say this is in the bathroom and this is in our downstairs toilet. That's going to be the furthest tap away from where the water's stored. So we could have, we'll call it 10 meters worth of pipework there. So you've got hot water stored in here ready to go, but you've not used this tap, say overnight, you've woke up in the morning and the first time you use this tap, you've got to wait for 10 meters worth of water that's in this pipe and got cold to come out of your tap before the hot water from the cylinder arrives at it. When you've used the tap, you might leave it an hour before you use it again. The water in this 10 meters worth of pipe is going to cool down. You're going to have the same problem again. When you open the tap, you've got to wait for the hot water to get to it. It's a lot of time to wait, and it's a lot of waste water and wasted energy. The actual rule, if we look in the book, where possible, the system should be designed to provide a temperature of no less than 50 degrees within 30 seconds. So you shouldn't have to wait more than 30 seconds with opening a tap, but even 30 seconds is quite a long time to be stood waiting for your hot water to come out of the tap. Now imagine this was in a bigger building, office block, hotel, hospital. The stored water could be hundreds of meters away from the tap. You're not going to wait that long. You're not going to waste that much water waiting for the hot water to arrive at the tap. So in these instances, they fit something called a secondary return or secondary circulation. So from the furthest tap, the last tap on the system, so we created a circuit now, and then we put a pump on, bronze or stainless steel pump. The reason it's bronze or stainless steel is because it can't be a corrosive pump. We don't want rust in the water. And then that pump will be powered. We're just going to put it onto a basic time switch. So now with this pump running, it's going to be pumping the hot water that's stored in here in a circuit around like that. So when you're not running the tap, it's just going to be pumping hot water around like that. So rather than this pipe being allowed to cool, it's constantly at the temperature of the hot water stored in the cylinder because it's being pumped round. So now when we go to open the tap, rather than wait for the water to come from here and go all the way along to the tap, it's already being pumped straight past the tap like that. So we've only got to wait for this short length of water before the hot reaches the outlet. A lot less waste, a lot less time to wait. And this will be on for all of the taps on the system. You could have bath tap, bathroom basin, kitchen tap, whatever. All the outlets now, rather than wait for the water to come from the cylinder, it's being pumped right before the outlet, so you've got hardly any time to wait. The pump, I have to basically explain the power to it. In a domestic house, you don't need this hot water available in the middle of the night while you're asleep, maybe during the day while you're at work. So you just set it on a timer. So it's on in the morning, on in the evening, and then not running when you're asleep in bed. So that pump would come on. If you woke up in the middle of the night, say, and the pump was off, and you wanted to use some water from this tap, you would just have to wait as if the secondary circulation wasn't in there. There will be a non-return valve on this pipe here to stop it from coming backwards. It would still come out the traditional way. If you buy an unvented cylinder, say 200 litres plus, this tap in would probably be factory fitted already there. If you were going to retrofit onto an old cylinder, you would have to put that tap in yourself, and you put it in the top third of the cylinder. So like that, because we know the cold comes in from the bottom, it's going to be cooler down here. You don't want to be mixing the cooler water with the hotter water, because it will reduce your outlet temperature. This is a very basic method of doing it. There's other ways of doing it. You could use a pipe stat, so it's monitoring the temperature that's in the pipe to maintain that. But just in a domestic house, you'll normally find it's on a time switch, like we've just seen in the job that I'm on. One of the most common questions you'll see when people are talking about secondary returns is, can you do it in plastic pipe? The answer is no. I'm just going to show you now on the SpeedFit John Guest website why you can't. So this is just the John Guest SpeedFit technical information. You can freely get this off their website. So if we scroll down to the sort of technical capabilities of the pipe, it tells you, even here on connection to boilers, recommends a minimum of 1 metre from the boiler should be in copper before you change to SpeedFit. But this is the bit we're concerned with: continuously operated recirculating systems, so secondary circulation for hot water. It basically tells you what secondary circulation is, but right at the bottom it says products must not be used on any continuously operated recirculating system, as they are not approved under the current standards. So you can't use normal, what I would call normal plastic pipe. You can, however, use MLCP, multi-layer pipe, because it's got a metal liner in it. And this is quite an interesting paragraph, actually. If you read through this, it gives you some reasons why you can't use standard plastic pipe. So hopefully that's explained. Basically, a secondary circulation, secondary return is just a loop of hot water that's pumped around the building, so that the draw-offs to the taps and the outlets, you don't have to wait for it to come from where your water is stored. It's being pumped right past the outlets, ready for you. So drain down, cut all the pipe work back to what we still need to obviously use: the heat and flow, heat and return, the gas, probably cut them a bit higher. Flow to the cylinder, return from the cylinder, and then we'll just take them to the new boiler location. And then this is the wiring centre. So we've got obviously a programmer, a 3-port and a 2-port. All this wiring is going to go, and we're going to have a new wiring centre, a Vaillant specific wiring centre. I can't think of the code at the minute. So I'm just going to decommission all this. Obviously we've got the power off, isolated, and yeah, we'll just start tidying it up, and then we'll have a bit of, when we got the boiler off the wall, we'll have a nice blank canvas to start again, hopefully. Yeah. This cable here comes along into this timer and then into our bronze pump for the secondary return. So just the most simplest way of explaining this: you don't need that pump running when you're not going to be using the hot taps, because why would you want to make hot water available when you don't need it? So you'd put it on a timer so it wasn't running all the time in the middle of the night when you don't need it. So you can just set what time of day you want that pump to run to pump the extra water circuit around the house. So that's going to go. Obviously we're going to keep the pump, that's going to be wired in, but we don't need that timer, because hopefully this control setup we've got, the boiler will do it for us. So Marcus likes using footprints.
Quality tool for a quality engineer.
The reason they call them footprints is because they leave a big massive footprint on every pipe or nut you touch with them. They just chew it to fork. That's our live neutral and earth going into our new wiring centre. That's got to stay because that's the immersion heater that connects in down there. But everything else is gone. Obviously we've got the pump, secondary return pump that's got to come across and get in. But yeah, all those wires are now gone, so just take all that trunking off the wall because you don't need it. Take that off. This is, the boiler's off now. This is the old wall plate. So central heat and flow, central heat and return. It could be used as a combi, so that would have been your hot water outlet and your mains water in. But it was a system boiler, and you've got the optional 22mm secondary return. Now let's go and see what in the boiler what that was doing.
2 returns, but it was never wired into.
So this is inside the boiler. So this is a central heat and flow here. Goes up into the main heat exchanger. And then this is that secondary return. It goes into the side of this hydraulic block behind the pump, and there's a stepper motor on it. So whether that was controlled, opened and closed to let that circulate, and then the return back. So yeah, I don't know how it would work. Someone will know. Someone in the comments will know.
Yeah, bit of a strange one.
That's for the scrap man now though.
Yeah.
It's for him to worry about. Can you talk us through this state-of-the-art tool you're using? Is this the new Wearer ratcheting Zyklop?
Yeah, it does everything this does.
He's got all the gear, but he's using a Tommy bar with a screwdriver.
I just can't be bothered to go to my van. Is the
Typical
basics of
plumber.
it.
Everything on the van,
Laziness.
you just can't be bothered. So you just
Laziness. But what it's doing is it's showing apprentices how they can adapt tools to work on everything.
yeah, you don't need the fancy expensive stuff.
No.
You can just mangle together an old screwdriver and a Tommy bar.
Yeah.
These buckets, I love them. Shape of them, they're sturdy. I mean, I've had this 2 or 3 years. Still brand new if I give it a clean. But it's got this nice cut out here, so you can sit your flue on it. It's fell in the bucket ready to take in the job. Yeah, I probably should have checked if you can still buy these buckets, but if you can, it's a great bucket. Yeah, have a Google, Halterfor's bucket.
315 internal.
315 internal. So that's the centre of first bend. Centre. First bend done. Then we want internal to internal 315, which I've already marked on there. And all I've done on that is got my spare piece of copper. That's where I took my measurement from. There's our 315, there's our upright. We're using the inside measurement, so that's why we're lining up with the inside. So that's the second bend done. Okay, so again, we'll do it again. So that bit there goes up to the boiler that I'm handing you.
This bit?
No, the bit
that bit.
That goes up to the boiler. Come on, baby.
Whoa, look at that, straight in. So what we're doing is we're going to fit an extra expansion vessel, because this system's got about 16 radiators on it. Even though there's one inside the boiler, it's not really man enough to take all the expansion. So yeah, we're going to stick this on just to give it that little bit of extra. Now normally they come with like a bracket that goes on the wall, and it goes on there. You have a bit of strap banding that you really struggle tightening up. So what we're going to do, we're going to fit this bracket.
Check this out.
Which is nice, solid. So that basically bolts to the wall, and then you screw that in there.
Oh, it's got a bleed valve on it.
Yeah,
and
bleed
then
valve
we'll put
on.
a isolation.
Yeah.
So we can service it if we need to. Yeah, so on the boiler, what would you say, about 12 rads?
10 to 12
10 to 12 rads off the expansion vessel that comes factory fitted inside a boiler. So if you've got bigger systems, you can put, I mean, that's a relatively small one, but if you've got, you work out how much pressure you need, how much expansion you need, and you can size them, so you could have an even bigger one if you needed it. Similar to ones with water cylinders. Obviously that size, what's that, 18 litres?
Yeah, I think it was 18. Well, that's 25.
That's a 25, so that's probably too big for that.
Yeah.
But if your tank was twice the size, you'd have the next size up, because you need more expansion, because you've got more water volume. So yeah, we're gonna put that on. We're gonna bang a T in the middle of those two clips there.
Yep.
Have that there.
And we're going to put a valve in, so we can turn it off with the drain off, so drain the water out, check the pressure in it.
Yeah.
Without draining the whole system.
because we're using press fittings, you can't put a normal drain cock into a press fitting because the tail's not long enough. You need to use the drain cocks with the longer tails, e.g. the ones you'd use on speed fit, they're long enough. So I just want to show you this. So this is a new next gen drain valve. I've just got to unpack it because it comes in a little pack. So that's the drain valve. So you can see the tail's long enough to go all the way into a press fitting. So that's why we're using it on this job. It's got this hose lock attachment, so you can put hose lock hose onto it. Just put the rubber on if you want to. If not, you can just use it as a normal, put a normal hose on there. And then this insert, it's like a polymer plastic one with a dome, so there's no washer in there. So the idea is that you'll never have to re-washer it. And also you can buy these separate and put them into existing drain cocks. So you can take the washer out, put that in, and then this just screws back together. Let's put this in here. So that goes in, that screws on, and then you use a 4mm hex key, once that's on there, to tighten that down. Yeah, now these have been coming in onto market for probably 3 or 4 years. I had my first one about 4 years ago. I had a prototype one, and it's a good idea. They're not the best looking for if you was putting them, like, say, underneath a radiator in someone's kitchen, but in a plant room or near an unvented cylinder, they're not that bad. But they've had problems with them. So, and I've had the problem as well, where I fitted a couple of these on a job, put them together, they were fine, and got called back because they were dripping. And there was an issue with the, I don't know if it was the plastic or the thread, but they weren't quite right. So hopefully, Marcus, this one's a good one, because they just had a few bad ones in the batch, I think. Yeah. But yeah, that's the next gen drain valve. So you can buy the whole thing, or you can just buy the insert to retrofit into old valves. Right, we're on day 2. Bit of a messy stage because there's a lot going on at the minute. I'm doing the wiring. We've got the thoroughflush connected, so there's the cold filling loop. We've just come off that. These hoses running down here, and then we've got the flow and return connected on our Spirotech filters using the Spirotech adapters. So Marcus is going to talk through with you what he's doing with regards to the thoroughflush. Now, if you've not seen a thoroughflush before, that's the unit, and it comes in a couple of bags. You get, what you say, 30 meters of hose, all the adapters to get it onto Magna Cleans, straight onto pipework, onto the Spiro adapters, and onto your machine, and you can cut your hoses to length. Now, the unit you get is that. This bit's extra. Marcus will just talk you through this now, because obviously we're hooking up onto the main supply, so we can't just do that and connect onto anything. Yeah. We've got to use backflow protection. So
it's obviously backflow protection on the filling loop using, but I've got this bit as well, just give it a bit of extra.
That's a double check valve.
Yeah, but I fit a pressure reducing valve on mine simply because we can get massive water pressure in Nottingham, anywhere between 4 to 6 bar, which I don't want going through the system. So I just adjust it to whatever I need. Standing pressure at the minute is 2, but it'll probably be about 1.5 when we're running. So basically we have cold mains coming in to the inlet, and then when we open the inlet, the water will go through A or B. Well, we're on A, so the water will go up through A, mains pressure around the system, all the way back down through B, and then out to a drain that you can see we've got over there.
So we just connected this up to one of the downstairs radiators. Obviously we've got the water isolated, so when Marcus opens that, let me just go and stand near the drain.
Yeah. You probably
so it's closed at the minute. See the water starting to turn a bit black now. So basically we're just flushing mains water through one rad at a time. While we're doing that, we'll use the agitator and a drill, agitate the rad. So that's pretty black now. And keep doing that until it starts to run clear. So we'll get this one running clear, then we'll come back to look at it. Right, so now we've got it running clear. What we'll do, I'll show you on the unit. So at the minute the mains is coming in and going through port A, so it's going this way round.
Yep.
And coming like this. Now we change it to B, and instead of going through A, it's going to go through B. And it should pick up some more crap. So that's reverse the flow. It should now. There you go. It's picking up some more, because we reversed the flow. Getting a bit more of the crap out. Won't be as much as the first time, but it's best to get it all out. And you can do that as many times as you want. You can reverse it forward, backwards, until you've got it running absolutely crystal clear. So while Marcus is outside doing the flush, I'm in here doing the wiring. This is the Vr71 wiring centre. It's basically a hub, it controls everything. So rather than have a normal wiring centre, we plug our components into these, and this does all the thinking for the whole system. We're going to connect the boiler to this and the controls to this using the bus. I'll talk about it properly when I've finished it, but basically I'm just wiring it up now. So our components, like 2-port valve, wires in. R6 is for hot water, R1 is for our first heating zone, R2 and R3 would be for additional heating zones. R4 is our secondary return pump, and then these connections here, these low voltage ones, these go to stats, like we've got one here on the central heating flow, and then there's one that connects into the cylinder. So basically this is monitoring the temperatures in the system, but yeah, I'll wire this up and then we'll talk through how it works properly at the end. Right, we're power's on, boiler's fired up. Obviously there's a lot of wires. We're going to tidy these up with some trunking afterwards, but we just want to make sure it works first. So yeah, we've got the 2-zone valves connected in, secondary circulation pump, power to the unit, power to the boiler, and then all these sensor cables and the E-bus cables, which is the sort of intelligent low voltage from the boiler. So the boiler E-bus goes into that, which goes into that, and then into this. The one thing with the Wago on, so because this isn't a Vaillant cylinder, it's a third-party cylinder, we've had to keep on the overheat cutout stat. So basically the overheat stat, the live from the board to open the valve goes through the overheat stat, and if that's okay, comes back and then goes to the valve. If that overheat stat trips, then the power won't come back up to open the zone valve. And yeah, I've got the clamp there, the one that goes in with the cylinder in this pocket, sensing the temperatures. So yeah, now we're just going to play around with it a bit, and then when we're happy it's all working, we'll have to just tidy these cables up. But the flush has all been done, pipe work's done, extra expansion vessel's done, the weather comp sensors, that's wireless, that's on outside. So yeah, we're back cracked, didn't we?
It's the outdoor weather sensor. It's got a little solar panel on, so it's rechargeable.
Nice.
Yeah. Job done.
Right, all up and working. All I've done with the cables, just cable tied them, because it was going to be hard. They go all over the place. It's going to be hard to get them in any kind of neat order. Air separator, dirt separator. We've put the PRV on a compression elbow so we can get the condense trap out. Moves out the way easy. Expansion vessel on its nice bracket. And yeah. You happy with that, mate? Have I worked hard?
You've worked hard, pal.
So we've just commissioned the boiler, filled the benchmark in. We showed you before in the last Vaillant we do a lot of the technical stuff like range rating, flow rates, temperatures, blah blah blah, from the installer menu on the boiler. But on this job, because we've got this senso, we've done most of it, well in fact we did all of it from this. The only thing we did at the boiler was the purge mode. So Marcus is just going to show you quickly the touch control senso comfort.
As he bashes his back on the old TP. So Should pull the cover off. Should we have left that?
Oh, look at that peel.
Should have left that for the customer really, but hey. So on the top, you've got a little button. You press that, wakes it up. Gives you all your information. Obviously, time, standard, air humidity. Well, we're in a garage, so it's bound to be quite high up.
Is that? Oh, is the air humidity from the outdoor sensor, the weathercom one, or is it from this?
Comes actually from this.
So we've got the outdoor temperature from that weathercom that's on the wall.
Yeah. Desired temperature, we've got it turned up. Current temperature because we're in. Loaded. And then we can do everything from here.
Just show that slide control on the side.
So you
just
slide it down, or you can tap it up. So we'll go information. So it gives you your water temperature,
water pressure,
current room air humidity. So it obviously picks up the air humidity from there. Control elements, competent person. I don't know who that could be, but it's obviously not me. And then serial number if you need the serial number.
Sexy. Is that going mounted on the wall, or is that freestanding?
She wants it freestanding at the minute. She's decorating. She don't want to get it covered in paint. But then to up the temperature, just click up. Click the tick. However long you want to do it for, you can do it more or less. However long you want to override it for, click the tick, and that's it.
You like it? Are you impressed with that?
Yeah, pretty impressive, isn't it? Easy to use. That's the main thing. Gives the boiler full modulation as well.
Have you enjoyed this job? Is that the first one of these you've done?
Yeah, first one of these sensos I've done yet. Obviously with the Wi-Fi enablement as well.
Yeah.
See, with it being in a garage, she wants to be able to see everything. She can do it all off the phone. Basically, what she sees there, she sees on the phone.
So, just for the obviously the guys following me that knew, did you suggest this system?
Yes.
Is it something you've been wanting to try one?
Yeah,
and you thought this job
definitely,
suits that?
It suits it because also she can time a secondary hot water pump off it as well.
Yeah.
Whereas with just the V Smart, you can only do one circuit and one heating zone.
Right.
One heating, one hot
so
water.
basically you came to this job, she needed a new boiler, you got one hot water zone, one heating zone, but you've got a secondary return on the hot water.
Yep.
You just wanted to find a system that would do that, and this was...
That was one of the big things she asked for. She said she hated having to come in here, because if you remember originally there was a timer clock here to override the secondary hot water pump.
Yeah.
So she wanted to be able to control everything from in the house, so I thought this was an ideal. Plus I like Vaillant controls because they actually talk to the boiler and modulate them a lot better.
Yeah. We both like Vaillant, don't we?
Yeah.
What's your second choice boiler?
Glowworm.
Is it?
Yeah.
And then you fitted a few A-tags as well,
Yeah, I've
haven't
done
you?
a few A-tags as well. Their controllers was fantastic.
And you're a service agent for A-tag. You can service and repair them.
Yeah.
But you'd say Vaillant's your top.
Yeah, Vaillant's my top choice now.
I'm Vaillant and then Baxi.
Well, you know what Baxy's all about, don't you?
Why don't you like Baxi? Come on.
No, they're a good boiler.
Yeah.
I just prefer Vaillant, obviously, for the backup.
Yeah.
Yeah, obviously, if it was a landlord job, you know, maybe Baxy's a good choice for them. Slightly cheaper, but it's still a good boiler, isn't it?
Yeah. Have you enjoyed working with me?
I always enjoy working with you.
Tell the truth. I turn up late, don't I?
Turns up late.
Well, I turn up late because we're in Nottingham and I don't live in Nottingham. You do, so you always get here before me.
Yeah.
But turn up late worth the wait.
What about when I work in Loughborough?
I know, you're always early. How do you do it?
I'm always early.
Right, say bye.
Bye. Have a good one, guys.
Right, we're done. Hope you've enjoyed that. Like I said at the start, that's the first one of those I've ever done, so hopefully I've explained it right. Apologies if I've got anything wrong, but yeah, that's it. Thanks for watching.